In this video, we are going to be talking about the product rule of differentiation. The product rule of differentiation shows the relationship between functions that are being multiplied with each other. In the previous video, we have already talked about how to differentiate using the general rule of differentiation, and we gave some rules like if we have y equals to ax, y equals to a x raised power n, our dy upon dx will be equals to nax raised power n minus 1. And we say that for differentiation, the coefficient is going to increase by the value of the power, and the value of the power is going to decrease by 1 whenever we are differentiating. And we also give some other rules like if y equals to k, like 1, 2, 3, and so on, our dy over dx equals to what? Equals to 0. If y equals to sine x, our dy upon dx equals to cos x. If y equals to cos x, our dy upon dx equals to minus sin x. If y equals to tan x, our dy over dx equals to sec squared x. If y equals to ln x, our dy over dx equals to 1 over x. And we said the differentiation of exponential x equals to exponential x. So today we are now going to be showing how can we differentiate functions that are having multiplication as their relationship. Like multiplication is the relationship between two functions. Let us take for an example. If we have a differentiation between two functions like y equals to u multiplied by v, or in some other cases we call it uv, what will be our dy dx? If we use the first principle of differentiation, like we have already said, we are going to be having our dy upon dx to be equals to u multiplied by dv upon dx plus v multiplied by du upon dx. And in some textbooks, they write as what? They write as u dv upon dx plus v du upon dx. So this is the formula that we're going to be using for calculating what? For calculating the product rule of differentiation. Now, let us take for an example. We won't really prove much. We're just going to be using what? We're going to be using examples to explain how we can apply this particular rule of differentiation. Let's take for an example that we have question like y equals to exponential x sine x. Exponential x sine x. So how are we going to do this? What we're just going to do is that we are going to partition this into two functions. And those two functions are what? The first one will be exponential x. Our exponential x will be u. And our sine x will be what? Will be v. So, which means we can write that u equals to exponential x and v equals to sine x. We have this already. Now, the next thing is that we can now differentiate u with respect to x. Which means if we differentiate the u with respect to x, we are still going to be having exponential x because differentiation of exponential x equals to exponential x. And now, if we now differentiate our v with respect to x, which is the v upon the x, differentiation of sine x equals to what? Equals to cos x. Therefore, what you're just going to do is that, remember we said that our formula equals to, if you want to look for our dy upon the x, equals to u dv upon the x plus v du upon the x, right? So in this case, what is our u? Our u equals to exponential x. So I'm going to write that exponential x. What is our dv? Our dv equals to cos x. That's exponential x cos x. Plus, what is our v? Our v equals to sine x. So we're going to be having sine x multiplied by du upon the x, which equals to exponential x. So the next thing we can do here is that we have common factors. We have exponential x here, we have exponential x here, which means I can what? I can factorize outside. Which means my answer is eventually going to give me what? It's going to give me my dy upon the x to be equals to exponential x into bracket sine x plus cos x. And that will be our answer for this particular question. Now, let us take another example. Let's say that we have question like let's say we have question like y equals to x squared plus 3 ln x. What are we going to do? The first thing we're going to do is to partition in this into two. We're going to partition it into two functions. The first one is that we look at this one, it's a single function. We look at this one, it's a single function, which means you can write this one as u and you can write this one as v. You understand? So the next thing is that we can say that let our u equals to x squared plus 3 and our v equals to ln x. So the u upon the x will be equals to what? Will be equals to, if you differentiate this one, remember that ax raised power n equals to nax n minus 1, right? So if you differentiate x squared, you are going to be having 2 multiplied by x, 2 minus 1. If you differentiate constant number, which is 3, is going to give you 0, which means answer for this one equals to 2x raised power 1, which is same thing as 2x. So if you differentiate this one, which is what? Which is ln x, is going to be giving us what? Is going to be giving us ln x is going to be giving us 1 over x, because differentiation of ln x equals to 1 over x. So I'm going to say that dv upon the x equals to 1 over x. You understand? Dv upon the x equals to 1 over x. So the next thing we are going to do is to take it one by one. From the formula, we have our formula to be the y upon the x to be u dv upon the x plus v du upon the x. And that will be equals to what? That will be equals to, what is our u? Our u is x squared plus 3. So I'm going to say that that is x squared plus 3 multiplied by u dv, that is multiplied by 1 over x, plus v du. What's our v? Our v is ln x, so that is ln x multiplied by du, which is 2x, ln x multiplied by 2x, which means our answer can be equals to what? Can be equals to dy upon the x equals to x squared plus 3 divided by x plus 2x ln x. And this can be, we can stop here. This will be our answer. So this is our answer for this particular question. So you can see, this is how we can differentiate whenever we're having functions that have multiplication as the relationship between them. Let us take another example. Let us say we have y equals to x is power 4 cos x, for example. X is power 4 cos x. Therefore, how are we going to do this? We can just say that our y, our u rather, u equals to x is power 4, u equals to x is power 4, and v equals to what? Equals to cos x, right? Therefore, the u upon the x equals to 4x is power 3. Remember the way we used to do it, the 4 will come to the back and we subtract 1 from this. That is 4x is power 4 minus 1, and that will give us 4x is power 3. So our cos x equals to minus sin x, which means the v upon the x equals to minus sin x. So the next thing we're going to do is that we're just going to say that the y upon the x, which is the expression of y with respect to x, will now be equals to u multiplied by dv, and that's going to give us what? This one multiplied by this one is going to give us minus x is power 4 sin x, because of the minus that is here, plus this one multiplied by this one, which is v multiplied by the u, is going to give us what? 4x is power 3 cos x. So this can be our answer. And we can decide to proceed by factorizing out the common factor, which is x and x that is here. How many x do we have here? We have 4. How many do we have here? We have 3. So we can say that that is practically equals to, I can factorize out x is power 3. So I'm going to be having x, or minus x rather, minus x sin x plus 4 cos x. And this will be our answer for this particular question. So what we just did is that we factorize out the common factor. So if we say that x is power 3 multiplied by x, we are going to be having x is power 4. X is power 3 multiplied by 4, we are going to be having x is power 3. So let us take another example. Let us say where we have our y to be equals to, x is power 5 exponential x, for example, we have this. How are we going to do this? Very, very easy. We're just going to say that what? We're going to say that y, our u equals to x is power 5, and our v equals to exponential x. Our du upon the x equals to 5x is power 4, and our dv upon the x equals to still exponential x. So what's the next thing we can do? Just multiply u with the v and multiply v with the u. As simple as that. So if this one multiply this one, we're going to be having our dy upon the x to be equals to what? To be equals to x is power 5 exponential x plus 5x is power 4 exponential x. So we can equally say that we can factorize this exponential outside, and we're going to be having exponential x into brackets exponential 5 plus 5x squared 4. We can even still proceed because we have x here, we have x is power 4 here. I can say that let me factorize exponential x and exponential and x is power 4 outside. So I'm going to be having x plus 5 inside. So if this one multiply this one, we are going to be having this. If this one multiply this one, we are going to be having this. As simple as that. Can proceed like that. Now, this is how to solve differentiation whenever we are having um product rule. You understand? Now, since we have been dealing with it, we have been dealing with only two functions. You understand? What if we have three functions? That's the question. What if we have three functions? Let us say we have our y to be equals to u multiplied by v multiplied by z. You understand? U, v, and z. How are we going to solve that? We're just going to say that our dy upon dx is going to be uv, something like this. It's going to be uv uv dz upon dx plus uz dv upon dx plus vz du upon dx. That is if we have three functions. Let us take for an example. Let us say that we have our y to be equals to 3x squared cos x sin x. What is our u? Our u equals to 3x squared, right? What is our du upon dx? That will be equals to 6x, right? 6x. What is our v? Our v equals to cos x. What is our dv upon dx? That's equals to what? That's equals to minus sin x. What is our u? Our u equals to sin x. And what is our du upon dx? Sorry. What's our dz rather? Sorry. That is u, v, and z, right? Our z equals to sin x rather. Our z equals to sin x. And our dz upon dx will be equals to what? Will be equals to cos x. So this is our u, v, and z. You understand? So we have already know that our u equals to 3x squared, right? Like we said before. And our du upon dx equals to 6x. So the next thing is that dy upon dx will now be equals to what? Will now be equals to, remember the way we said it? We said uv multiplied by dz upon dx. What's our u? Our u is 3x squared. Then v is cos x. So that will be 3x squared cos x. 3x squared cos x. Then I say that uv then dz upon dx. What is dz upon dx? That's equals to what? That is still cos x. You understand? So that is cos x multiplied by cos x. Plus the next one is now what? The next one is now, we said uv dz upon the next one is uz dv upon dx. Uz, what's our u? Our u is still 3x squared. 3x squared dz upon the u uz. What's our z? That is sin x multiplied by, you now say that dv upon dx. What's our dv upon dx? That's equals to minus sin x. So that is multiplied by minus sin x. multiplied by minus sine x plus the next one is what? The next one is Vz. What's our V? Our V is cos x. Our Z is sine x. And our dv upon the u upon the x is now equals to what? Is now equals to multiply by 6x. So the next thing we can do here is that we can rearrange. Cos x multiplied by cos x will give us cos squared x. Sin x multiplied by sin x is give us sin squared x. So that will be equals to what? Therefore, our dy upon dx will be equals to 3x squared cos squared x plus, or I will say that minus because of the minus that is there. So I'm going to say minus 3x squared sine squared x, because sine x multiplied by sine x equals to sine squared x, then plus cos x sine x multiplied by what? Multiplied by 6x. So I'm going to say that plus 6x cos x sine x. So what we are going to do is that we can now factorize out. You understand? We can factorize out in a way that we can say that what? We can say that this, in this case, if you look at it very well, we have 3x squared here, right? And we have 3x squared here, right? I can decide that what I want to do is that what? I'm going to be having what? I'm going to be having my 3x squared outside. So I'm going to be having 3x squared out here into brackets cos squared x minus sine squared x. You understand? Plus, next one is what? 6x cos x sine x, right? And we can conclude our answer in this form. So this is how to solve product rule of differentiation. In the next video, we are going to be talking about the quotient rule of differentiation. So the next video, don't forget to subscribe to this particular channel. Thank you.